This is pre-calculus notes on section 6.4. Exact trig values. Exact trig values in all 4 quadrants. This is probably the hardest lesson that you've gotten in trigonometry so far. So you're going to need some practice on this. It's also important. All right, so whenever I'm using the phrase exact, you've heard me say this before, but I have to remind you, you are not allowed to use the calculator, and you're not allowed to use decimals. No calculator, no decimals. Okay? You're going to have all of your answers in simplest fraction, simplest radical form, and you're going to have to use your trig card. All right, let's get started with this problem. Okay. There we go. Took too long to erase that. All right, so what I want to do first is I am going to draw a copy of this angle, and I'm going to see if I can find the reference angle, okay? 5 pi over 4, I want to try and figure out which quadrant that's in. Again, it's sometimes easy to think about these as mixed numbers instead of improper fractions that kind of help you figure that out. So if I were to take 5 and divide it by 4, I've got 1, remainder 1. So this is 1 1/4 pi. All right, so that means there's 0, here's pi over 2, here's pi, here's 3 pi over 2. Okay, that means that this angle has to be more than half a circle. But 1/4 is less than 1/2, so it's not more than 3 pi over 2. So it has to end in quadrant 3. Okay, the reference angle is going to be the positive acute angle formed by the terminal side of theta and the x-axis. It's going to be that green part there. So I'm going to subtract pi. I'm going to subtract this much to find the reference angle. So theta prime is equal to 5 pi over 4. That was the angle that was given. Subtract pi. I need a common denominator. Multiply top and bottom by 4. So I have 5 pi over 4. Subtract 4 pi over 4, which is equal to pi over 4. So my reference angle, my theta prime, is pi over 4. So now, why is that important? Well, that's because the absolute value of the trig ratios of theta, okay, are equal to the trig ratios of theta prime. So in other words, all I have to do is figure out the trig ratios of theta prime and then attach the correct sign to them to determine if they're positive or negative. So this is a quadrant 3 angle, all right? And so in quadrant 3, all students calculus tangent is positive, but sine and cosine are negative. Okay, so let's write the 6. Here's another really important part. Let's make another page. Okay, here's that trig card. All right. So what we're going to do is we are going to find my reference angle on the trig card. Here it is, pi over 4. All right, so my 6 trigonometric ratios are the absolute values of my 6 trig functions of 5 pi over 4 are going to be all on that pi over 4 line, okay? All right, so here I go. sine of 5 pi over 4. Okay, sine is negative in quadrant 3, so the answer will be negative. And the sine is square root of 2 over 2. Okay. Shall I do the reciprocal while I'm right here? Cosecant of 5 pi over 4. Trying to move this over so I'm over. Okay, there we go. Cosecant of 5 pi over 4 is going to be the reciprocal of sine. It is going to also be negative, and the reciprocal of sine, using my trig card, cosecant is square root of 2. Okay. Cosine. Okay, cosine is also negative in quadrant 3. According to my trig card, cosine of pi over 4 is square root of 2 over 2. So I've got negative square root of 2 over 2. And the reciprocal of cosine is secant. Okay, so I've got, again, negative square root of 2. Tangent of 5 pi over 4. Tangent is positive in quadrant 3. So, according to my trig card, tangent is equal to 1. Okay. Tangent is 1, and the reciprocal of tangent also 1. Okay, so these 6 answers are what I'm looking for. This is really important that you should be able to do this. Next problem. All right, 5 pi over 3. Again, let's try and figure out which quadrant that's in. 5 divided by 3 is 1. So I've got 1 2/3 pi. Okay, that's going to be a quadrant 4 angle. Okay, it's more than a pi. It's 2/3 is more than is more than half of pi. So it has to go over here into quadrant 4. So theta prime, the positive acute angle formed by the terminal side of theta and the x-axis. Okay, there it is. To find theta prime, I'm going to subtract 5 pi over 3 from 2 pi. 2 pi, subtract 5 pi over 3. I need a common denominator. I'm going to multiply top and bottom by 3. So that gives me 6 pi over 3. Subtract 5 pi over 3 equals pi over 3. So theta prime is pi over 3. All right. So I'm looking for the pi over 3 row. Okay, pi over 3 is right here. So we're using that row to determine my 6 trig ratios. All right, so before I do that too, let me also consider the signs. So all students take calculus. Cosine is positive in quadrant 4. That means sine is negative and tangent is negative. All right, so here we go. The sine of 5 pi over 3 equals, the sign is going to be negative, so it's negative square root of 3 over 2. Okay, I'm going to do the reciprocal too. So the cosecant, there's cosecant of 5 pi over 3 is, it's going to be negative. Right, the reciprocal is 2 square root of 3 over 3. 2 square root of 3 over 3. Okay. Let's do cosine. So the cosine of 5 pi over 3. All right, cosine is positive in quadrant 4. Okay, so it's 1/2, positive 1/2. And the reciprocal of cosine is secant. The secant of 5 pi over 3 is going to be 2 because it's the reciprocal of 1/2. Tangent of 5 pi over 3. Tangent is negative in quadrant 4, so this answer will be negative. Tangent is square root of 3 for that reference angle. So I've got negative square root of 3. Okay, and then the cotangent is the reciprocal of that. It's also going to be negative square root of 3 over 3. There they are. All right. Again, I would have liked to show you more examples, but these videos are too long, so goodbye for now.